18.2 question 4. It tells us an oxygen cylinder contains 0.5 kilograms of gas. So our mass of the gas is 0.5 kilograms. We write these things down as we go. At a pressure of 0.5 meganewtons per square meter, so megapascals if you prefer, and a temperature of 7 degrees C, which is 7 plus 273, which is 300? No, 280. 280. Let's get that right. Yeah, which is 280 degrees Kelvin. Okay, so those are our initial conditions there. What mass of oxygen must be pumped into the cylinder to raise its pressure? So that's mass 1, pressure 1, temperature 1. To raise its pressure, so pressure 2 is 3.0 meganewtons per square meter. At a temperature, T2, of 27 degrees C. Which is 300 Kelvin. So we don't know M2. Now the problem here is we've got masses, and what we really want is n's, because we want to use PV equals nRT. And we can't because we've got mass, and what we need is number of moles. However, we do know that the number of moles N is equal to the mass of the gas divided by the relative molecular mass of the gas. So we can replace N with M over Mr. So what we can do is we can rewrite this equation, PV equals mass over Mr RT. Now, because the relative molecular mass of the gas is the same and R is a constant, these two are both constants, and these two change, the mass and the temperature. So it kind of makes more sense for us to write PV equals M times R over MRT. And so P1, V1, M1, T1 for the initial state, and P2, V2, M2, T2 for the final state. So if we were to do that for the initial state, and then for the final state, we've got P2, V2 equals M2 R over relative molecular mass times T2. And we divide this equation by this equation, simultaneous equation, solving style. We get P1, V1 equals M1, T1 over P2, V2 on this side over M2, T2. Or equivalently, which might make this a little bit easier, P1, V1 over M1, T1 equals P2, V2 over M2, T2. That's what you're going to use to solve the question. These are the numbers you're going to plug into it. Hopefully, from this point, you can solve it.